Here are a couple of extra examples for Objective 2. The first thing you'll notice about Objective 2 is all of the functions are being presented in factored form. That's a really nice gift right now. There's going to come a time where it isn't factored and you're going to have to factor it. But for right now, just appreciate the fact that the equation or the function is given in factored form. So, example number 1, use the following characteristics to help you graph. Let's find the x-intercepts and let's note their multiplicity if not 1. So, in factored form, -3 is definitely one of the factors, but it doesn't help us get a solution because -3 cannot ever equal 0. So, even though it's a factor, it doesn't help us get a solution. So moving on to the next one. X plus 4 quantity squared equals 0. So x equals -4 would definitely be one of the solutions or one of the x-intercepts. And notice it came from a squared factor. That means its multiplicity is 2. Now, all that means is when we go to graph it, we don't pass through -4. When we hit it, we bounce off of it. Now, another one, x equals +1, and another one, x equals -5. And since those two have multiplicity 1, we really don't have to note it. Now, the y-intercept, let's set x equal to 0 and solve the equation. Well, we'd have this -3. Now, when x equals 0, 0 plus 4 is 4. And then the equation tells us to square it. So 4 squared is 16. Substitute 0 right there. 0 minus 1 is -1. 0 plus 5 is +5. And when you multiply these out, you get a product of 240. So what that tells us is that's the y-intercept. Now the last thing we need is the very first term in the expansion. We don't have to expand the whole thing. This would be a nightmare to figure out what this is in its totally multiplied out form. But we do need to figure out the first term. The first term would be -3 times this x squared times this x times that x. So that would be -3x to the 4th power. Now we need to start figuring out what that tells us. Now, Objective 1 actually told us that. If you have your notes from Objective 1, you're going to want to know that table. If you already have it memorized, good for you, because you're going to need it memorized. So what does -3x to the 4th power tells us? Well, it tells us the power is even, and the leading coefficient is negative. So when there's an even power and a negative leading coefficient, the end behavior is low to low, which means the graph starts low and it ends low. Now the last thing we need to do is put these key points that we just found on the graph, and let's label them. So the first 3 key points we found were the x-intercepts. Okay. One of them was -4. So let's kind of estimate where -4 might be. It might be about right there. And note it. X equals +1. X equals +1 would be maybe right there. X equals -5 would be maybe right there. Now we also found one other key point. Remember that y-intercept at +240? Let's say positive 240 is just right up here. Now, if we did have scales, we'd have to make sure the x scales were the same and the y scales were the same, but the x scales and the y scales don't have to be the same. Let's go low to low. Everything should now work. If we start low, what do we do when we hit negative 5? Well, since negative 5 was a multiplicity 1, it passes through. But then we have to come back at some point in time and we have to hit negative 4. So let's do that. Let's pass through. Let's start low. Let's pass through. Let's turn. And then what happens when we hit negative 4? Negative 4 was multiplicity 2. So that means I need to bounce at negative 4. And then I have to come up and hit 240. And then on my way down, I have to hit 1, and I have to pass through again. So there's a representation of the graph. Not an incredibly good one, but that's a representation of the graph. If you were to graph this actually on Desmos or on a graphing calculator, you would see that the graph had these characteristics. Now, just as one final check, you have to ask yourself, does it do everything that it was supposed to do? Does it go through negative 5, negative 4, and positive 1? The answer is yes. When it hit negative 4, since that was a multiplicity 2, did it bounce at negative 4 instead of passing through? And the answer is yes. Did it hit 240 on the y-axis because that's the y-intercept? The answer is yes. And did the overall graph start low and end low? And the answer is yes. So that's a representation of this graph. The second and final example for objective 2. Notice this function is again factored, and like I said before, really appreciate the fact that the problem has been factored for you. It makes so many things easier. So first thing, let's identify the x-intercepts and their multiplicity if not 1. Well, here are the three factors, 4x, x plus 3, and x minus 6. This first one, 4x, I can equal 0. If I set 4x equal to 0, I can actually get an answer, and that answer is x equals 0. So that's one of the x-intercepts. Now, x plus 3 equals 0, we know that gives us a solution of x equals negative 3, or an x-intercept, or a 0. And the third one, x equals positive 6 is another 0 or another root. And so these are the three x-intercepts. Now, we don't have to note any of them because they all have a multiplicity of 1. None of them come from a squared factor. So they all have multiplicity of 1. We might as well graph them right now. X equals 0 would be right there. X equals negative 3. Let's call negative 3 right there. And let's call positive 6. Something about like right there. So here's 0. There's negative 3. And there's negative 6. Now let's find the y-intercept. Where is this graph going to cross the y-axis? We always set x equal to 0 and solve the equation. So 4 times 0 would be 0. Multiplied by 0 plus 3, which is 3. And 0 minus 6, I'm just substituting 0 for x. So 0 minus 6 is negative 6. And 0 times 3 times negative 6 is 0. So the y-intercept for this graph is also 0. Now let's explore the leading coefficient. The leading coefficient, if we expanded this whole thing out, the very first term would be 4x times another x times another x, which would be 4x cubed. Now, that tells us it's an odd degree polynomial, and the leading coefficient is positive. So odd positives have a certain characteristic, and that characteristic is they go from low to high. So when we start graphing this, we need to make sure all of that happens. We need to start low, and since -3 is from a multiplicity 1 factor, it passes through. In fact, all of these are pass-throughs. None of them are bounces. So I start low, I pass through. At some point in time, I make a turn to get back here to 0. And I come down, and at some point in time, I turn and I go back to -6. And I pass through again. Remember, one more time, all of those points were pass-through points. And one last thing, now let's check. Did I hit all the points I was supposed to hit? Yes. 0, -3, -6. Were they pass-throughs everywhere? Yep, pass-through, pass-through, pass-through. Did the graph do what it was supposed to do? Go from low to high? And the answer is yes, it did. And was the y-intercept also 0? The answer is yes. So you know you did it right. Now, what if you had to graph this function only x minus 4? What would you do to these key points? And that would just be shift 4 units to the right. We learned that, I think it was in Unit 1. Now, what if it was f of x and then the plus 5 was added after the function? Shift 5 units up. And then the last one, what if it was the opposite of f of x? That would be a reflect across the x-axis. And that's objective 2.